at number one. We'll talk about it. We'll see if we can kind of navigate the landscape a little bit, and then we'll go from there. All right. So it says the area of Beth's rectangular garden is x squared plus 13x plus 42 square feet. The width is x plus 6 feet. We want to know what the length of the garden is. And you might look at this and say, well, how am I supposed to do that? You know, all the usual things that people would say. You'd never taught us this. You know, it's not fair. You know, blah, blah, yakety schmackety. But the reality is we have plenty of information here. It just doesn't seem like it at first glance. They said rectangular garden, all right? And then they told us square feet. All right. I was reading an article yesterday, and it's kind of unfortunately going to give you a sense of where I am in my life, that I'm reading articles on like math. Not like lessons on math, but like what people think about math. It's like I'm here teaching math and exploring math, and then I go home and I'm like reading more articles about math. And it's like, where did it all go wrong? You know, but it was fascinating because I went from college directly to being a teacher. There are a lot of people that go to college, become other things first, and then become teachers after that. So they have a little bit more context. So the question of what are we ever going to use this for might better actually be answered by those people than someone like me who just went directly into teaching. I had to research it in order to know really. I mean, I have some idea, but not as much as somebody who maybe was an engineer at some point, all right? But this article I was reading about said that really the only thing that the engineers care about are measurement and units. Like the math always works itself out because you could always grab a textbook, you could always look online, you could always figure out the rule, you know, just research the rule. But accuracy and measurement and knowing what the units are the driving force behind being able to actually build something and have that something last. All right. So, I mean, we're in the rudimentary stages. You're just learning about the basics of it. But you look at something like feet squared, that's telling you a lot. You know, you might not realize it at first, but it's actually the key to being able to handle this entire problem. That one little thing that I highlighted there. Feet squared is a measure of what? Area. All right? And because I have two things highlighted, one rectangular and one a symbol representing area, I now know that I'm dealing with the area of a rectangle, which is length times width. All right? So they told us that the area is x squared plus 13x plus 42 square feet, and they gave us the width. Now they're asking us to find the length. When you put it like that, it kind of makes sense. Like, okay, they gave you the area, they gave you one dimension, what's the other? Now, you know, flashback to, I guess it would be third or fourth grade because my son's in fourth grade and this is what he's doing right now. He's actually working with some variables. I don't know. Do you remember working with variables in third or fourth grade? No. Common Core. It's great. Anyway, it's not in the way that you might think. They're not working with these variables. They're working with like y's instead of x's. No, it's not that bad. But the area is x squared plus 13x plus 42. The length is unknown. That's what we're here to find out. The width is given as x plus 6. So this is my length. So if I just figure that out, I have the answer. All right? So something times x plus 6 is going to give me that trinomial x squared plus 13x plus 42. All right? So I would have to think about, all right, what do I have to multiply the x by in order to get an x squared? An x. What would I have to multiply the 6 by in order to get a positive 42?
7.
A positive 7. So we answer the question. The length has to be x plus 7. All right. Now, you might look at this and say, well, people aren't measuring the length of gardens in terms of x. They're not going to say x plus 7 is my length and x plus 6 is my width. All right. And my answer to that is, well, how do you know? You're not a gardener. And then you say, yes, I am. I do it every weekend. And we go back and forth for half an hour, and then nobody gets anywhere. Honestly, we don't know. And that is kind of the point. You don't know what this stuff is being used for. So you just have to assume that having a variable length or width could be important. All right? Maybe not to an individual gardener, but maybe to somebody who's determining appropriate lengths of fencing to sell. Like you're a supplier, you're the manufacturer of fencing, and you're going to sell certain lengths to Home Depot to sell to consumers out there. You would want to know how many of one type of dimension you should have and how many of another type. So variable quantities might make sense.
So when you figure out the length and the width, where would you get the 13x from if you could solve it?
A wonderful question. It's kind of a hidden term because it seems to disappear. But if you were to FOIL that out, the x plus 7, x plus 6, you'd get an outer term of 6x and an inner term of 7x. Put those together, you get the 13x. All right, so it's kind of sneaky. It's hidden in there, but it's there. All right. So now we have a length and a width. I need the perimeter in terms of x. So the perimeter. What's the formula for the perimeter of a rectangle? 2L plus 2W. All right. So I'm going to take my perimeter equals, and I'm going to write 2 times x plus 7 plus 2 times x plus 6. Now, the question didn't ask us to simplify. If this were a test, you may or may not have to simplify. If it's a multiple choice question, you got to be prepared for all possibilities. All right, because maybe this is not a choice, but its simplified form is. If it's a free response question, you just leave it like this. All right, so let's simplify it just so you get the experience. All right, I'm going to run through with the 2, a little distributive property in both cases. Oops. So 2 times x plus 7, 2x plus 14. Then 2 times x plus 6, 2x plus 12. Combine my like terms, and what do I get? 4x plus 26. All right. Now that's a measure of, what are my units? Feet. All right. So, yeah, basically, it's kind of weird to think about this, but what we're doing is generalizing so that the width has to be at minimum a certain measure. The width has to be at least 6 feet, because if x is equal to 0, well, actually, I guess it could be even smaller than that, but it stops making sense after a certain point. But it has to be a minimum value, and then the length has to always be 1 foot more than the width. All right, so you're guaranteeing that dimensional relationship is always going to be in place. All right, so now we can actually draw conclusions about any type of rectangle that has that characteristic. All right. Find the cost of the fence, or cost to fence the garden when x is equal to 5. So all that's telling us to do is replace the x in my perimeter function with a 5. So I'm going to write p of 5. So I'm going back to my functions unit. All right, that was the one with the stations assessment that everybody loved. All that notation is telling me to do is replace my x with a 5 and simplify, and I'm looking at 46 feet. All right, we always have to have the units when we're dealing with application questions. All right, I'm going to re-emphasize that over and over again before we take the test. because I absolutely hate taking off points when people forget to put the units. All right, so it's out of a selfish need that I'm going to continuously remind you. All right, so don't forget the units. Let's find the cost of fertilizer. All right. So, I'm sorry, cost to fence the garden. So that's actually the perimeter. That's how much distance around the garden. But what we need to do is actually think about what that would translate to in terms of a cost. So right at the top of your paper, I'm just going to suggest that you write cost is equal to unit price times the number of units. All right, it's a generalization of something that I think that's common sense. If I told you that a Hershey's with almonds cost 75 cents, that's my favorite. That's my go-to. Right? But then I told you you're going to buy 10 of them. How much you paying? $7.50. Right? You just took the unit price, how much each one of them cost, and multiplied it by the number that you were going to purchase. All right, then factor in tax and all that stuff. But in this case, I have 46 of the units. The units are feet. So 46 multiplied by the unit price, 46 feet multiplied by 2. Now this is dollars. Oh, a little typo for somebody. I'll explain in a sec. Yeah, it has to do with the table. Honestly, I think the only thing you could submit would be to say, this is page 20, right? So on page 20, fix units in table, and the race is on.
You'll check the time.
Yeah, whoever gets it in first. Now, that being said, you never know whether or not people are at the max, because you max out at 3 bonus points per quarter. So sometimes people are like, yes, I got it in, but they're up to like their 13th submission. So yeah, well then there you go. But I just want people to build the habit of always trying to submit.
What if the timestamp's the same?
It always puts it in the order, like in my queue. Yeah. So even if it's a heartbeat before, it's always going to be there. Yeah, these should be the units. The fertilizer is dollars per square foot, and the fencing is dollars per foot. All right, so when I multiply, I'm going to get 92 just dollars. All right, and that's because it's kind of weird to think about this, but the units are algebraic expressions also. You'll learn this a little bit more in science class, but you'll also learn it in math class. If you have 46 feet and you multiply that by 2, and I'll write it out, $2 per 1 foot. It's really 46 times each individual foot, 2 times each dollar, and 1 times each individual foot. This is an algebraic variable. This is like an x. All right? They actually cancel out because anything divided by itself would be equal to 1. And so that's where you get your 92. The only units that remain are dollars.
Why'd you multiply by 2?
Oh, because that's the value, the cost for fencing. I've found throughout all the years that I've been doing this, more and more every year, that the biggest thing or the biggest hindrance for people actually fully understanding concepts in math is units, right? Because they remember the steps, they remember the general process. they get a number, they don't know what the number means. Right? If you can take the time and start thinking about what the number means, it does pay off in the end. All right. Now we're saying what's the cost of the fertilizer when x is equal to 5. So you got to think about it. Now, here's an important piece, because going back to C, I kind of glossed over this. I used a perimeter formula or equation. You might have said, well, how did you know perimeter? Why not area? And that comes from the context of the problem. And I don't think you need to be a gardener in order to understand this. If you're going to fence in a garden, that fence is going to go around the outer edge, right? The outer edge of a geometric figure is the perimeter, right? If you're going to fertilize the garden, are you just going to fertilize the outer edge? No, you're going to get all the space in the middle, right? All the space in the middle in the two-dimensional plane is known as area. So I'm going to plug this into my area formula. And you can choose whichever variation you want, because x squared plus 13x plus 42 is the same thing as x plus 7 times x plus 6. I like the x plus 7, x plus 6 better. If you're putting it in your calculator, it doesn't make a difference one way or the other. In terms of difficulty. But if you're doing it in your head, personally, I'd rather, I wrote 7 twice for some crazy reason. I would rather multiply 12 by 11 than figure out what 5 squared plus 13 times 5 plus 42 would be. Just personal preference. Right? Either way, what do you get? Well, what's 12 times 11? That's the easier calculation. Also known as 144 minus 12.
132.
132. So it's 132. Yeah. Yeah, it's one of those things.
Where'd you get the 7 and 6 from?
I grabbed it from this model here,
okay.
Replacing each x with a 5.
Okay.
Yeah, Common Core was trying to get you to be better at mental math, like tape diagrams. Does that sound familiar? Yeah. The whole point behind that was for you to actually start doing that stuff in your head. I try to explain this to my son, and I think he gets it. He still doesn't understand necessarily why he has to draw the tape diagram every time, but he does it because he's a doer. You know, you ask him to do stuff, he does it. But when you're just like figuring out different quantities, it's just an organizational strategy. You know, now they're doing partial products and partial sums and stuff like that, and it's like, well, you know that quick mini aside here. It's crazy. Those partial products, really, all they're trying to get you to do is take something like, let's say 12 times 5. All it's trying to get you to do is to look at the 12 as a 10 and a 2. Two separate things, because they always want you to make a 10 group. It's like, why always a 10 group? Because 10 is the easiest number to multiply by aside from 0 and 1. All right? You're going to take that and multiply it by a 5. You're going to take that and multiply it by a 5. All right? So you get the 50, you get the 10, results 60.
I mean, yeah, that's kind of smart.
Right. But really what you're doing is applying the distributive property. All right? But it's behind the scenes. Now, you look at this and say, okay, well, why would I have to write that out every time? Common Core was never trying to get you to write that out every time. They were trying to get you to do that in your head. They were trying to get you to a point where you would say, okay, if I got to do 22 times 5, well, 20 is an easy number to work with. So let me take the 20 multiplied by 5, let me take the 2 multiplied by 5, get the results and put them together. All right, that's all that stuff was trying to get you to do. So when I did my multiplication here, I had to do 12 times 11. Well, okay, maybe I don't know 12 times 11, but I do know 12 times 12 is 144, so I need one group of 12 taken away from that. So So take the number you know and then just manipulate away from that value, right? And this is all without a calculator, right? Now, all that being said, now I have to take that 132 and multiply it by 0.28, which I'm not doing in my head. Right? So it does beg the question of like, well, if I got to use my calculator anyway, why do I got to do it in my head at all? It's just practice. 30, say it again?
I think it's 36.96.
36.96. All right. Find the total cost to fence and fertilize Beth's garden when x is equal to 5. What should I do there?
Add them.
Add those two values together. Get the sum. $128.96?
Yeah.